Now let's start A2 chemistry. Today is your first class, right?
Yes, sir. I was with you in the demo session as well.
Okay. So I think this is your demo.
No, sir, we have already done the demo.
Okay, okay. So do you have this session in which we discuss the syllabus of the A2 chemistry?
Yes, sir.
Okay. It's better to start from the first lecture, right? So this is your first lecture. Let's suppose this is your first lecture, right? So A2, basically A2 chemistry consists of 1, 2, 3, 4, and 5 sections, right? First section is physical chemistry, in which we study chemical energetic, electrochemistry, chemical kinetic, and equilibrium. And second section is inorganic chemistry, group 2, transition metals. And in organic chemistry, we have different chapters, right? In analytical chemistry, we have 3 chapters. And the fifth one is all content of AS. So basically, you have 5 sections. So sometime total 7 questions are there, sometime 11 questions, sometime 9 questions, right? So physical chemistry got 2 questions, and inorganic chemistry from inorganic chemistry examiner took 2 questions and 1 question from analytical chemistry and the remaining one from the organic chemistry. Are you getting my point, Bide?
Yes, sir.
Okay. Now, assessment. In assessment, you have 2 papers, right? Paper 4 and paper 5. Paper 4 is structural type and paper 5 is planning, analysis, and evaluation type. For paper 1, you have 100 marks and time duration is 2 hours. In paper 5, total marks 30 and duration is 1 hour 15 minutes. Now look at the weightage of all papers. Paper 1 weightage is 15.5%, paper 2 is 23.0, and paper 3 is 11.5. So total 50% for from AS. And in paper 4, you have 38.5% weightage, right? And 11.5% for paper 5. So total 50%. So you can easily understand the weightage of the paper 4. Now, can I ask one question,
Yes, sir.
Alia? What is your grade in
Sir, for
AS?
AS, my grade is A in chemistry.
In chemistry. So you have to work
Yes,
hard.
sir. It's A.
Sorry?
A, sir.
Mashallah, mashallah, mashallah. I'm really sorry. I am really sorry. I thought E. I'm sorry.
It's okay, sir.
Okay. So we have different section, right? Chemical energetic, electrochemistry, chemical kinetic, and equilibrium, right? So let's start from first chapter, chemical energetic, right? Are you ready for the first chapter?
Yes, sir.
Okay. So this is the syllabus of the first part of the uh, chemical energetic, right? So I summarize the whole chapter. So first Born-Haber cycle, then certain definitions, right? Then give free energy. This is your syllabus, right? So first question, first question or first topic is lattice energy, right? First question is lattice energy. Now make the heading lattice energy. So what is lattice energy? 9701 within 42 May June 2004. Examiner asked, define the term lattice energy. So always remember lattice energy is, let's suppose you have sodium ion. Let's suppose you have sodium positive ion. This is in the gaseous state. Sodium positive ion in gaseous state. Here you have chlorine ion in gaseous state. When these two gaseous cation and anion combine, ionic solid is formed. Ionic solid is formed and energy is released. This energy is called lattice energy. Are you getting my point?
Yes, sir.
So energy change when 1 mole of ionic solid is formed. This definition is for 2 marks. So 1 mark for this statement that energy change when 1 mole of ionic solid is formed from its gaseous ions. Such release energy is called lattice energy. Alia, are you getting?
Yes, sir, I'm getting.
Okay. Next question. Write equation to show lattice energy. Write equation to show lattice energy. Write equation. Write equation to show lattice energy. So first example is, as we have discussed, sodium gaseous combined with Cl negative and form NaCl, right? Now second equation is Na2O. Na2O. Now Alia, can you tell me how many sodium do you have in it?
Sir, 2 sodium.
2 sodium. 2 sodium. 2 sodium. So write 2 sodium positive gaseous. So can you tell me the anion of oxygen?
Sir, O2 negative. Gaseous.
O O2 negative or O2 negative? Okay. O2 negative. O2 negative. Now when we combine these two, Na2O is formed. This is solid and delta H is lattice energy, which is negative. Now, Ali, are you listening to my voice?
Yes, sir.
Now, write ionic equation for MgCl2. Write ionic equation for MgCl2. Write ionic equation for MgCl2. This is May June variant 42 2004. Right? Yes. MgCl2 2004. Yes, Ali, can you tell me?
Sir, Mg2 positive gaseous.
Mg2 positive gaseous
Plus 2Cl negative gaseous.
plus 2Cl negative gaseous
Gives MgCl2 solid.
Okay. MgCl2 solid. This is called lattice energy, right? Whenever ionic compound is formed, release energy is negative and known as lattice energy. Now, 9701 October number variant 42 2005 AGBR. AGBR. So how to write the equation for the lattice energy? So here we have ionic solid. Here we have calcium chloride. Here we have MgO. So first of all, write the cation with the gaseous one, and then write the Br negative gaseous and join together to form ionic solid. Energy is released. This energy is called lattice energy. Yes, Aliya, can you do 2009 October number 41? Can you tell me how to write?
Sir, Ca2 plus gaseous
Ca2 plus gaseous. Very good. Gaseous cation
plus 2Cl negative gaseous
plus 2Cl negative gaseous ion
gives CaCl2 solid.
gives CaCl2 solid along with the energy. Now, can you solve for MgO?
Sir, Mg2 plus gaseous
Mg2 plus gaseous
plus O2 negative gaseous
plus O2 negative gaseous
gives MgO solid plus energy.
MgO solid. So lattice energy is the energy which is only used for the ionic compound. Lattice energy is only for ionic compound. It is not for the covalent compound. Whenever ionic solid is formed from gaseous cation, gaseous anion, energy is released. This energy is called lattice energy. Now PbCl2. Yes. Fahim, are you in the class?
Yes, sir.
Yes, sir.
Okay.
Assalamualaikum,
Okay,
sir.
Fahim. Islam. Fahim, we are just starting A2 chemistry, right? So can you tell, do you know what is lattice energy?
Yes, sir.
Yes. What is lattice energy?
Sir, energy, uh, it's
Now
difficult.
listen. Don't
Yes.
worry. Whenever you have gaseous cation and gaseous anion, whenever they combine, ionic solid is formed. Energy is released. This energy is called lattice energy. Can you repeat?
Yes, sir. When gaseous and cations and anions combine to form ionic solids.
Exactly. Energy is released. Now look at
Energy.
this example. Look at this example. Lead, right? You know that lead has positive 2 charge. So gaseous lead combined with 2Cl minus gaseous. Both are cation and anion. Whenever they combine, they form ionic solid. This ionic solid releases energy. This releasing energy is called lattice energy. Whenever, whenever, whenever ionic compound is formed, energy is released. Such energy is called lattice energy. Yes, Alia. Now this is your
Um,
homework. But tell me in the class, right? Yes. Na2SO4. Yes.
Sir, 2Na plus gaseous
2Na plus gaseous.
plus SO4 2 minus gaseous
Very good. SO4 2 minus gaseous.
Gives Na2SO4 solid.
Gives Na2SO4 solid. Very good. Yes, Fahim. K3PO4.
Yes, sir. 3K positive gaseous
Very good. 3K positive gaseous.
and PO4 3 negative.
PO4 3 negative gaseous. Fam, this
Make
is first chapter, chemical energetic of A2, physical chemistry, right?
okay, sir. Yes.
K3PO4 solid. Yes, Alia. All are from past paper. All are from past paper. Yes.
Sir, 3 Na plus gaseous.
Oh, very good. 3 Na positive gaseous. Now I am changing the question. I am changing the question. Now your question is yes. Now, yes. Alia,
Sir,
tell me the
Na plus gaseous.
Na plus gaseous. Yes.
So this is a nitride ion, so the charge is
This is
supposed
not
to
a
be
nitride ion. This is not a nitride ion. This is azide ion. Azide. This is not a nitride ion. Nitride ion is NO3 minus. There is no oxygen in it. This is azide. Azide. Yes. You know that the sodium has negative charge. Sodium has positive 1 charge. So this is N3 minus 1. Are you getting my point? This is from the past paper. Are you getting my point, Alia?
so sir the charge can't be -3 for azide ion.
As azide ion is negative 1 because its cation is sodium and sodium has plus 1 charge. So N3 become minus 1. This
Okay,
is
sir.
this N3 is a molecule, or you can say that uh, this is anion, anion with molecular form. So NaN3 solid. This is lattice energy. Yes, Fahim, calcium phosphate.
Yes, sir. 3 calcium 2 positive.
3 calcium 2 positive. Very good. But in
Yes.
gaseous state,
Yes, sir. And
hmm,
2 PO4 3 minus.
2 PO4 3 minus
Yes, yes.
gaseous.
Sir.
Hmm.
To form Ca3 PO4 2.
Ca3PO4 2. But in solid state, right?
Yes, sir.
Yes, Alia. Next,
Sir, 2Al3 positive gaseous
2Al3 positive gaseous,
plus 3 2O negative gaseous
3O2 negative gaseous. Very good.
gives Al2O3 solid.
Gives Al2O3 solid. Very good. Yes, Fahim.
Yes, sir. Mg2 plus gaseous
Mg2 plus gaseous. Yes.
plus 2 OH minus gaseous.
Plus
Hydroxide
2OH minus hydroxide gaseous. Very good.
to form magnesium hydroxide MgOH2.
To form magnesium hydroxide solid. So I think these questions are enough to write the latest energy, right? Fine, this is our syllabus, right? We have physical chemistry. In physical chemistry, we have 4 chapters, right? In physical chemistry, we have 4 chapters: chemical energetic, electrochemistry, chemical kinetic, equilibrium. Right? Examiner gives 2 questions from physical chemistry, mostly. Second is inorganic chemistry. In inorganic chemistry, you have only 1 chapter, transition metal, but few questions from group 2. So inorganic portion of inorganic chemistry, 2 questions. you have a section analytical chemistry, one question from analytical chemistry, one question, while remaining question from organic chemistry. Fahim, are you getting my point?
Yes sir, yes sir. आप इसी
So we,
order में syllabus
हाँ
रखेंगे. First physical, फिर inorganic, फिर organic, फिर
हाँ
फिर
बिल्कुल बिल्कुल इसी तरह से पहले फिजिकल फिर इनऑर्गेनिक एंड देन ऑर्गेनिक, राइट? हो सकता है कि मैं पहले फिजिकल लेके ऑर्गेनिक ले जाऊं, ठीक है?
okay sir.
So now
जी sir.
now write the question. Why lattice energy is exothermic? Now write the question. Why lattice energy is exothermic for 2 marks? Yes, Alia, why? Why lattice energy is exothermic?
So new bonds are formed and bond formation is exothermic.
Wow. New bonds are formed. Ionic bond is formed. I think it's better. Ionic bond is formed and bond forming is exothermic. Fahim, why lattice energy is exothermic?
So same reason. इसी वजह से
Same
new
reason.
bonds are formed.
No,
Bond
ionic bond is
formation is
formed.
exothermic.
Ionic bond is formed and bond forming is exothermic. Ionic bond is formed. Ionic bond is formed and bond forming is exothermic. Right? Now, Born-Haber cycle.
Yes.
Next is Born-Haber cycle. Born-Haber cycle. Ali, do you know what is Born-Haber cycle?
No, sir.
Okay. Born-Haber cycle, Born and Haber, these are two friends who established a cycle. This cycle is used to find the latest energy when a chemical reaction happens in multiple steps. For example, A convert into B and B convert into C and C convert into D and D convert into E. So multiple steps. So latest energy. So Born-Haber cycle, now you can write, right? Born-Haber cycle is a cycle which is used to find latest energy when any reaction happens in multiple steps. Born-Haber cycle is a cycle which is used to find latest energy indirectly when reaction happens in multiple steps. Have you written?
Yes, sir.
Okay. Alia, have you written?
Yes, sir.
Okay. Now, there are two types of Born-Haber cycle. Alia, this is my chemistry. Please. This is my chemistry. My chemistry means this is called cognitive method, right? This is my cognitive method. Chemistry is same, but methodology is different. This is called cognitive method, right? So I divide Born-Haber cycle in two steps, in two types. I name first type normal Born-Haber cycle. Normal Born-Haber cycle. And second one is abnormal Born-Haber cycle. You cannot find these two in any book or from the Google because this cognitive method is mine. Now, Alia, tell me, this is a salt. This is a salt, NaCl. Can both of you tell me how many elements are in anion or cation? How many elements in anion, in NaCl? Yes. How many
In
elements?
N,
One, that is Cl minus.
one, sir.
One element, correct. So if you have one element in anion, this is called normal bond-Haber cycle. Now, Na2O. Yes. How many elements in anion? Yes,
One, sir.
one. So this is called normal bond-Haber cycle. Number 3, AlCl3. Now, how many elements in anion?
One, sir.
Alia, how many elements in AlCl3 in anion?
Sir, 1.
One. So it is normal bond-Haber cycle. So in normal bond-Haber cycle, you have only one element in anion, or you can say that one element in cation. But focus on anion. In normal bond-Haber cycle, anion has only one element. Now tell me, KOH. Yes. How many elements in anion?
Two elements.
Two elements. This is abnormal bond-Haber cycle. Whenever you have more than one element in anion, such bond-Haber cycle is called abnormal bond-Haber cycle. Next is Ca3PO42. Yes. How many element?
Two, sir.
Two. So this is again abnormal bond-Haber cycle because anion has more than two element. Now next, K2CO3. Yes. Normal, abnormal?
Abnormal.
Abnormal. Why abnormal?
Sir, 2 elements in
Because
anion.
of the two elements.
Because of the because two elements are in anion. Now another identification of abnormal bond-Haber cycle. Equations are given. Equations are given. If equations are given, it means it is abnormal. You just follow the abnormal bond-Haber cycle method. So there are two identification of abnormal bond-Haber cycle. Number 1, anion has two or more elements. Number 2, equations are given in the exam, in the question. Yes, Fahim, how can you identify either the bond-Haber given question is given question belongs to normal bond-Haber cycle or abnormal bond-Haber cycle?
So through the elements present in the anion.
Yes, by the number of elements, right? And another method is another way is equations are given in the question, right? Either one equation or two equation is given. Yes,
For the
Alia,
ab
are you getting my point?
Yes, sir.
Okay. Fahim, are you getting my point?
yes, sir.
Okay. Now let's start normal bond-Haber cycle. Normal bond-Haber cycle. In normal bond-Haber cycle, you have 6 cases, maximum 6 cases. Case number 1. Case number 1, group 1 plus group 17. Example, sodium chloride. Example, sodium chloride. Example, sodium chloride. Now, Fahim, can you tell me the name of the cation present in NaCl?
Cl minus.
Cation.
Okay. Na plus.
Na plus. So write Na. Na is metal and it is solid. Right? So first we convert Na solid into gaseous. Energy is required to convert solid into gas. This energy is called H1. Yes, Alia, what is H1? Alia, what is H1?
So decomposition.
No. Solid convert into gas. Gaseous atom.
Atomization.
Atomization. This is atomization of sodium. H1 is atomization of sodium. Now sodium convert into Na positive gaseous. This is called H2. This is called H2. So electron is removed from sodium, minus electron. One electron is removed. Yes, Alia, whenever one electron is removed, energy is required. Can you tell me the name of the energy?
Endothermic.
No, what is the name of the energy? Whenever one electron is removed from gaseous atom, energy is required. Yes, Fahim?
So ionization energy.
Ionization energy. Very good. H2 is ionization energy of sodium. H2 is ionization energy of sodium. Now cation is ready to make ionic bond. Now cation is ready. Cation is ready to make ionic bond with the chlorine. Now look at the chlorine. Yes, you have Cl2 gaseous. Now tell me how many chlorine atom in the question. How many
Two, sir.
atoms? How many atoms in the
One.
question? One.
One.
But chlorine exists in diatomic form. So how can we change Cl2 into Cl?
Half Cl2.
Half Cl2, very good. So when we divide Cl2 by 2, you will get 1 Cl. So direct convert this Cl2 into Cl and write just near the sodium ion. Yes, Alia, can you tell me either the sodium positive make ionic bond with the chlorine or not?
No, sir, it's not. It's in gaseous form. It's not. It's not an. It's not an anion, sir.
Yes, very good. Sodium can make the bond because it is cation. Chlorine cannot because it is not an anion. So first, we convert chlorine to chlorine anion. How do we convert? By giving electron. We take the electron from the sodium and give it to the chlorine. Now, one electron is given to this chlorine. Now this time plus electron. Now this time plus electron. This energy is called H3. Yes. Can you tell me the name of this energy? When chlorine molecule convert into chlorine atom.
Atomization of chlorine.
Shabash, very good. This is atomization of chlorine. Atomization of chlorine. This is atomization of chlorine. Very good. Now, when one electron is given to chlorine atom, now one electron is given to chlorine atom. One electron is given to chlorine atom, energy is released. Now remember one thing, upward arrow means endothermic. Upward arrow means endothermic. Atomization is endothermic, ionization is endothermic. That's why I wrote upward arrow. Downward arrow means exothermic. Now can you tell me, when we remove one electron from any atom, energy is released. What happens when we give an electron to any atom? Either atom releases energy or require energy to accept this electron. Yes, Alia.
So it requires energy.
Require energy to accept the electron.
I think so, sir.
No, no, no. Why? Because you know that chlorine has nucleus. Nucleus is positive, right? Electron is negative. So there is attraction. Whenever proton attract electron, energy is released because attraction releases energy. Repulsion require energy. Attraction always releases energy. Are you getting my point?
Yes, sir.
Fahim?
Yes, sir.
Whenever electron is removed, this is called ionization energy. And ionization energy is required energy. But whenever you give electron to any atom, energy is released. And such energy is called electron affinity. And electron affinity is downward because it is exothermic. This is H4. Now, this chlorine become negative, gaseous, and sodium wants to make chlorine. That's why sodium is here. Now chlorine becomes Cl negative. Can you tell me either they form ionic bond right now or not? Are they ready to make ionic bond? Yes.
Yes,
Alia?
sir.
Yes, fine.
Yes.
Because both are gaseous ion. Now they form ionic bond. Now they form ionic bond. This is called NaCl solid. And this energy, yes. Can you tell me the name of the energy, H5?
So lattice energy.
Lattice energy of NaCl. Correct. And after the completion of the lattice energy, just combine these two elements. This is called formation. Formation, this is H6 formation. This energy is always formation because NaCl is formed from elements which are in their standard condition. Sodium is solid, chlorine gas. So this is called delta H formation of NaCl. Now the question is that how can we use this cycle to find lattice energy? Now you have to memorize two things. First thing is that delta HF is equal to sum of all enthalpies. Alia, uh, Alia, are you listening to my voice?
Oh, yes, sir.
Alia, I have doctorate in chemistry, right? That's why mostly I give you some short tricks, right? To solve a big question, right? So this is called DI. I call this is the technique DI, doctor instruction. DI stand for doctor instruction. These are very, very, very important points, right? Shortcut, short keys, right? How to find the latest energy by using this formula. Delta HF is equal to sum of all enthalpies. Now, Alia, can you tell me the number of the delta HF? Either it is H1, H2, H3, H4, H5, H6, H7. Can you tell me the number of delta HF?
Sir, 6.
6. So the formula is H6 is equal to H1 plus H2 plus H3 plus H4 plus H5. Now you can see that you can easily find the you can easily generate the formula by using my short trick known as DI. Delta HF is equal to sum of all enthalpies. This is my DI number 1. Fahim, are you getting my point or not?
Yes, sir. Yes.
Okay. Now next DI is that how to find atomization of non-metals. How to find the atomization of non-metals. This one. How to, this is non-metal. How to find the H3. Sometime H3 is not given in the exam. Sometime H3 is not given in the exam. So how to find H3 atomization of chlorine? So this is my DI number 2. DI number 2. Use this formula, bond energy divided by 2. Bond energy is given in your exam, right? Exam paper. So always use the formula bond energy divided by 2 and this number. Here you have 1. So write here 1 multiply by 1. So you can easily find the atomization of non-metal. If 2 is written here, so you will write here 2. If here you have 3, so you will write here 3. Are you getting my point? Just fine.
Yes, sir. Yes.
Alia, are you getting this point?
Yes, sir.
Now, can I move to another question? Yes. Have
Yes,
you
sir.
written this one?
Yes, sir.
Okay. Alia, can I move forward?
Oh, yes, sir.
Now, question number 2. Case 2. There are 6 cases, right? Case number 2, group 2 plus group 17. Example, calcium chloride. Calcium chloride. Now, Alia, how can I start? Yes, can you help me how to solve this calcium chloride?
So, sir, they'll be in the elemental form. So, calcium in the solid state and half Cl2 in the gaseous state.
No, first start from the calcium, right? So we have calcium solid, then
Then, sir, we atomize it.
atomization. So convert into calcium gas. Okay. Then this is called H1. Then
So then ionization, so Ca2 plus
okay,
gas.
remove one electron. So calcium plus one is formed. As you know that calcium has plus two charge. So remove electron step by step, right? Then
So then ionization again.
okay. So remove another electron. This is calcium plus 2. This is H2. This is H3. Then
So sir, now we can start with chlorine.
now we start the chlorine. Yes. Here we have Cl2 gas. So how many chlorine atoms in the question?
So 2 atoms.
2 atoms. So you have to divide it by 2 or not.
Yes sir, it will be half Cl2.
So if you divide it by 2, then you will get one chlorine. But in the question you have two chlorines are given.
So you'll not divide it by 2.
Not divide by 2, just convert into atoms. Now it convert into 2Cl gaseous. Alia, are you getting my point? Here you have two chlorine atoms, right? So if two chlorine atoms are given, so why did you divide it by 2?
So
Beta,
I
are you
thought
getting my point?
in the
Yes.
question.
Sorry?
So it should match the number of atoms which has been given in the question. It can't be one.
Yes. So that's why do not divide it by 2. When you divide it, let's suppose you divide it by 2. So you will get one chlorine, right? But in the question, two chlorines are given. We have to follow the question.
Okay, sir.
So no need to divide it by 2. So here you have two chlorine atom. This is called H4. Then Alia,
Then we ionize it.
means give these two electrons to it, right?
Yes, sir.
Okay. Then the direction of the uh, arrow is downward because this is electron affinity and electron affinity is exothermic, right? Why exothermic? Yes. Why first electron affinity is exothermic? Yes, Alia. Why electron affinity is exothermic?
So 1 mole of electrons is added, so it's exothermic.
It's exothermic because energy is released because of the attraction between the positive nucleus and negative electron. Whenever nucleus attract electron, whenever nucleus attract electron, energy is released. That's why electron affinity, first electron affinity is exothermic. Fahim, can you repeat why first electron affinity is exothermic?
Yes, sir.
Can you repeat why first electron affinity is exothermic?
Yes, sir. Because of second.
Hmm?
Yes, sir.
Can you repeat? Because
Just
nucleus has positive
sir,
charge.
because of the attraction between protons and negatively charged electrons.
Negatively charged electron.
Proton
Whenever,
attracts.
exactly. Due to the attraction, energy is released. Alia, can you repeat?
So due to the attraction of the electron with the nucleus of the atom, energy is released, so it's exothermic.
Very good. Now next is calcium is here because of the attraction of chlorine. Chlorine become negative, gaseous. Yes. Then
Sir, then they form CaCl2 solid.
sorry. Now
So
arrow
then
become
they
downward. Yes. Alia, can you
so they'll
repeat?
form CaCl2 solid.
CaCl2 solid, and this is H6. Then
Then we show the enthalpy change of formation.
enthalpy change of formation. Just join these two.
H7.
This is H7. Now, Alia, can you tell me what is H1?
So like the name of the energy?
No, can you name the energy when calcium solid convert into gaseous?
Sir, atomization,
Atomization of calcium. Okay. Now, what is H2?
ionization.
Which one? First or second?
First ionization. Sir.
First ionization energy of calcium. Then what is H3?
Second ionization energy of calcium.
Second ionization energy of calcium. Okay, very good. And what is H4?
Atomization of chlorine.
Atomization of chlorine. Very good. Very, very good. Atomization of chlorine. Can you tell me the formula of this? This was Di number 2. Yes.
So it was half of the bond energy.
Bond energy, half of the bond energy, always half of the bond energy. Multiply by?
1.
No. Always multiply by this number.
Oh,
Okay. So, Alia, multiply by?
2.
Multiply by 2.
Multiply by 2. Okay, very good. Then what is H5?
It's the ionization of calcium of chlorine. Sir.
Chlorine. This is called electron affinity, right?
Yes,
So
sir.
can you tell me how many chlorine atoms are there?
2.
2. Sir.
2. So you have to multiply it by 2 because this electron affinity is kilojoule per mole. This electron affinity is kilojoule per mole. But here you have 2 chlorine atom, so you have to multiply it by 2. This H5 is for 1 chlorine. For 2 chlorine, you have to multiply by 2. Are you getting my point?
Sir.
So H5 is 2 times electron affinity of chlorine. Alia, are you getting my point? Why we multiplied it by 2?
Yes, sir.
Because if 1 electron is gained, this is multiplied by 1. If 2 electrons are added, that's why multiply by 2. Now, Alia, what is H6?
So it's the lattice energy.
It's lattice energy of CaCl2. And what is H7? Yes,
Enthalpy change formation.
formation of
Calcium chloride.
calcium chloride. Now, what is the formula to find lattice energy? Yes. Give me in numbers. Either H1, either H2, either H3. Yes. DI number 1. Yes. What is the formula to find?
The H7 would be equal to H1 plus H2 plus
Exactly.
H3.
H7 is equal to H1 plus H2 plus H3 plus H4 plus H5 plus H6. Alia, are you getting this point or not?
I'm getting it, sir.
Alhamdulillah, Alhamdulillah, Alhamdulillah. Now next is Fahim,
Yes, sir.
case number 3. Case number 3. Group 13 plus group 17. Example is AlCl3. Yes. Yes, start, Fahim.
Yes, sir. So aluminium solid would be converted to aluminum gas.
Aluminium solid convert into aluminium gas.
Then ionize
Then remove one electron.
electron to form aluminium Al plus.
Al plus gaseous. Then
Again an electron would be removed to form Al2 plus.
again -1. Al plus 2.
Then again -1 to form
Again
Al
-1. Al plus 3.
gaseous. Yes.
Gaseous. So this is H1. This is H1.
H2.
This is H2. This is H3. This is H4. Then all should be
Then
in
so we
gaseous
start
state.
with
Yes,
then so we start with chlorine.
chlorine gaseous.
Yes.
So how many chlorine are required?
3. So you
3.
can write 3.
3/2. Very good. So first 3/2. 2 cancel. 3 chlorine atoms are there.
Yes, sir.
So you have 3 chlorine. 3 chlorine gaseous. Then
And then sir it would be electron affinity. So it will have Cl minus.
okay,
will
this is
gain
H5.
one.
Okay. So how many electrons are given? 3 electrons.
Yes.
Okay. So you have Al plus 3 gaseous and
And 3
3Cl
3Cl minus.
3Cl
Minus.
minus. So this is H6. Now you will multiply H6 by
H6 by 3.
3 because 3 electrons are
Oh.
added.
Yes, sir.
Okay. Now you can easily easily make ionic bond between aluminum and chlorine. This is AlCl3 solid. This is H7. Then fine. Then yes, Alia. Then
Then we show the enthalpy of formation.
enthalpy of formation. This is H8. Now, can anyone
And then
make
we'll
the
show
formula?
the enthalpy change of formation.
Enthalpy change of formation, right? Okay, fine. Now give me the formula.
So then we'll show the enthalpy change of formation.
Okay.
H8.
H8. Okay. So what? How to find the H5? Yes. Can you tell me the formula of H5? Fahim, Alia? Anyone? How to find the H5?
Sir, is it bond energy of chlorine divided by 2 times 3?
2 times 3. Very, very good. Very, very good. Shabash. Very good. Now, how to find the lattice energy? DI number 1. Yes.
So H8 equals to H1 plus
H8. Very good. Formation is equal to sum of all. H1 plus H2 plus H3 plus H4 plus H5 plus H6 plus H7 plus H7. Now case number 4. Case 4. Group 1 plus group 16. Example is sodium oxide. Yes, Alia. Now help me out to solve this Na2O.
Sir, we start with Na2 solid.
Na solid. Okay. Then
Sir, 2 molecules of Na, right?
2 molecule. Very good. 2 atoms, right? So write here 2. Yes.
And then we convert it to 2 Na gaseous.
2 Na gaseous. 2 Na gaseous. Then
Then it becomes 2 Na plus gaseous.
okay. So how many electrons are removed?
So 2 electrons.
2 electrons. Very good. 2 Na positive is formed. This is called H2. Then
So then
then
we start with oxygen, sir. So O
this is
gaseous.
O2. O2 gaseous.
So it will be half O2 gaseous.
Very good, very good, very good, very good. Because 1 oxygen is required. 1 oxygen gaseous. Then, then
So then it gains the electron, so it becomes O minus gaseous.
okay. 2 Na positive because of the affection of oxygen. Okay. Now, can you tell me the oxidation state of oxygen? Either it is -1 or -2.
So it's minus 2.
-2. So you have to give another one. You have to give another one. So give another electron.
So we have to show this in the same step, or do we show
In
two
the
different electronic
two
affinities?
different steps, because You know that you have two types of electron affinities. Fahim, are you in the class?
Yes, sir.
Okay. So you have to give another electron because oxygen is -2. Now, can you tell me the charge on electron? Can anyone tell me the charge on electron? Either it is positive or negative?
Negative.
Negative. And charge on oxygen?
Negative.
Negative. Either they attract or repel.
Repel.
If they repel, this energy is endothermic or exothermic?
Endothermic.
Endothermic. Very good. So it means this time arrow is upward. Ali, are you getting my point, Fahim? Are you getting this point?
Yes, sir.
This is sodium positive and this become oxygen -2, gaseous, gaseous. Now both are ready to form ionic bond. So ionic bond is formed. Ionic bond is formed. Now, can you tell me this is H3, this is H4, this is H5, this is H6, this is H7. Now, Alia, what would be the formula of H3?
So it will be the bond energy of oxygen divided by 2 times 1.
2 times 1. Very good. Very, very good. Very good. Now, H1 would be 2 times, H2 would be 2 times because there are two sodium atoms.
Yes, sir.
Now, what is H1? Yes,
Enthalpy change of atomization of sodium.
two times
Enthalpy.
enthalpy change of atomization of sodium. What is H2?
2 times ionization energy.
Energy of sodium. Very good. What is H3?
2 times atomization and no, not 2 times.
So atomization of oxygen.
Atomization of oxygen. Yes.
Okay, what is H4?
H4.
So is it the first electron affinity?
First electron affinity. Very good. First electron affinity of oxygen. Now, what is H5?
Second electron affinity.
Second electron affinity. Very good. Second electron affinity of O minus. Then what is H6?
So lattice energy.
Lattice energy.
Lattice energy. And what is H7?
Formation, enthalpy of formation of sodium oxide.
Of oxygen. And delta HF of, what is the formula?
Na2O.
Okay, what is the formula to find lattice energy?
Oh, H7 equals H1 plus H2 plus H3 plus
H1 plus H2 plus H3 plus H4 plus H5 plus H6 plus H6. Now next is case number 5. Case 5. Group 2 plus group 16. Example is calcium oxide. Yes. Now solve both of you and send me on my WhatsApp number or the group.
Okay, sir.
Now, Alias, solve this question.
Okay, sir.
Okay. Yes, have you done?
Yes, sir, almost done. Sir, why didn't we start with calcium in solid state?
Yes.
the charge.
Okay. Now send me your solution.
Okay, sir. Also, sir, ये वाली बात मुझे समझ नहीं आई, repulsion वाली. जो fourth step में, fifth step में, between the oxygen and the electron.
Fine, I will tell you.
Okay, sir. Okay.
Yes, Ayla. Have you done?
Yes, sir, I have done. I'm just sending it to you.
Okay. Fine.
सर मैंने आपको भेज दिया.
Okay. So calcium become, now remove one electron from it, it become +1. Then again remove electron, this is +2, gaseous. So correct. Then half O2, correct. Then oxygen gas, correct. Add one electron, it become -1. This become +2, correct. Then again add one electron, it become -2, it become +2. Mashallah, mashallah, mashallah. Mashallah, very good. Now, Fahim, calcium, calcium gas, calcium +1, calcium +2, one electron, half oxygen, oxygen -2, O -1, then O -2, calcium +2, then calcium oxide. You have to write calcium solid, right, Fahim? Right here, solid.
So where?
In the last,
Okay, okay,
here,
okay. Okay, sir.
well, everything is correct. Now, where is H1? What is H1? Hmm?
Yes, sir.
What?
Atomization.
So H1 is atomization of
Calcium.
calcium. Okay. And what is H2?
First ionization energy of calcium.
Okay. And what is H3?
Second ionization energy of calcium.
And what is H4?
Atomization of oxygen.
And what is the formula of H4?
Formula for H4, bond energy upon 2 into half.
into 1.
Sir, but
Here you have 1.
yeah, okay.
Okay.
ठीक है. Yes, sir.
What is H5? What is H5?
H5, first electron affinity of oxygen.
And what is H6?
Second electron affinity.
Of O minus.
O minus, yes.
Okay. And what is H7?
H7, lattice energy.
Lattice energy. And what is H8?
Enthalpy change of formation
Okay.
of calcium oxide.
Of calcium oxide. Now this is case number last 6, group 13 plus group 16. Example is Al2O3. Right? This is your homework. Solve and send it back to me. Right? Fine. Do you have any question? Ayla, do you have any question?
Sir, repulsion बारे में, about the between the oxygen and the electron.
Now listen, oxygen has negative charge and electron has negative charge, right? So when you give electron to oxygen, so oxygen is negatively charged. So negatively oxygen and electron both repel each other. So it is very difficult to oxygen to accept this electron because of the repulsion. That's why we must supply energy to overcome this repulsion to give this electron to oxygen. So because of this repulsion to overcome, energy is required. That's why second electron affinity is always negative, always positive. Same
Oh,
for third electron affinity, same for fourth electron affinity. Because of the repulsion, first electron affinity is always positive, exothermic negative. Why? Because it is due to the attraction between the positive nucleus and the electron. So whenever nucleus attract electron, energy is released. But after accepting an electron, oxygen becomes negatively charged. Now it does not have any capability to attract electron because of the repulsion created by negatively charge of the oxygen and electron. So they repel. It is very difficult to accept electron to accept by the oxygen. So we have to we provide energy to overcome this repulsion to accept the electron. Are you getting my point?
yes, sir, yes.
Okay. Aya, do you have any question?
Sir, then in first electron affinity,
Yes.
why isn't there version in that one also, sir?
Why first electron affinity is exothermic?
Yes, sir.
Okay. Now look at the boat, right? Let's suppose here we have oxygen. This is nucleus, right? This oxygen is positively charged. Why positive? Because of the nucleus, right? So this is upcoming electron. So this upcoming electron is attracted by the nucleus. When they attract electron, energy is released. That's why it is exothermic. Are you getting my point?
Yes, sir. But so there'll be electrons in the shell outside the nucleus, yeah. So why can't
Yes,
they be
yes,
repelled?
yes, yes. Because you know that they revolve continuously. So because of the when electron revolve, magnetic field is developed, right? Are you getting my point? This magnetic field cancelled the repulsion.
Which
So
magnetic,
nucleus, sorry,
which magnetic field?
whenever electron revolve around the nucleus, they create magnetic field, right?
Yes, sir.
So due to magnetic field, their repulsion is cancelled out. But mainly you can see that nucleus has 16 protons. So 16 protons attract one electron. So this attraction is enough to release the energy. You know that whenever we eat food, due to respiration, energy is released from our body. Similarly, whenever atom attract electron, energy is released. Ayla, are you getting my point or not?
Yes, sir, I'm getting.
Okay, but after accepting this electron, this become negative. Now it is very difficult to accept this electron because of the repulsion between negatively electron and negatively atom, right? After the completion of the Born-Haber cycle, I will give you the question: why first electron affinity is positive, negative? Why second electron affinity is positive, right? So after the completion of Born-Haber cycle, we will do all these questions again.
Okay, sir. Okay.
Today our topic is just Born-Haber cycle. After the completion of the 6 cases, we will start example past paper question. So total I will give you 18 questions. 18 questions from the past paper, inshallah.
Inshallah, sir.
Okay.
Okay.
Okay. Do
Yes,
you
sir.
have any question?
Sir, what about abnormal Born-Haber?
Inshallah, we will do it later.
Okay, sir. Okay.
Okay. Ira, do you have any question?
No, sir, it's clear.
Okay. Take care, beta. Allah Hafiz.
Allah Hafiz, sir.
Thank you, sir. God bless.
Allah Hafiz, beta.
Thank you, sir. Allah Hafiz.
Allah Hafiz, beta. Allah Hafiz.